Hey guys, welcome back in here. Mr. Marone, getting you ready for lesson 3-4. There's only one video for this section and for our next section, so it's a little bit shorter stuff. And what we're going to look at is collections of rigid motions. So it's wonderful to be able to do rotations and reflections and translations, but it's even better to do them together, or to look at combining them and utilizing them at the same time. So we're going to take a look at that and kind of dig into that today. Before we do that, quick shout out to period 9. We just went over our test results yesterday, and you guys beat out the other classes by a very narrow margin, so I give you a little bit of a shout out. Periods 2 and 8, you were very close. Make sure to knock them off their perch. They're getting a little cocky. Okay, so let's dig into this. So the idea of a rigid motion and a composition of rigid motions, we've already kind of talked about once. And we're going to make sure to just highlight some important details. So 2 or more rigid motions can occur. The big key is in the rule. So they've given us this statement. When you do a rigid motion composition, you always work from the inside out. So in this example, N composition of M, that little circle in the middle, tells me to perform the transformation M first, then the transformation N. So the order does matter when it comes to these compositions of transformations. You do have to work from the inside out. So I want to dig right into an example. So we're going to look right here at this graph and try to determine if there is a rigid motion or a composition of rigid motions that maps our original pre-image in black to our image in red. And if we look closely at it, what I do to determine whether or not it is a rigid motion that gets it there is I look at the side lengths. In this triangle, AC has a length of 2 units, and A prime C prime has a length of 2 units. And I look at BC. BC has a length of 3 units, and B prime C prime has a length of 3 units. And since they're right triangles, I know that there's only one way to create the same right triangle with sides 2 and 3. We could do the Pythagorean theorem work if we wanted to, but it gives us the verification that we do in fact have triangles that are the same, so we can say that there are a collection of rigid motions that happen that allow us to map ABC to A prime, B prime, C prime. So we can say yes to that first question. Now, looking closely at our figure, they ask, does a reflection, a translation, or a rotation map A prime, ABC to A prime, B prime, C prime? If we look closely, point A is the leftmost point in our original, in our pre-image, and it's the rightmost point in our image. The only way that the orientation of the figure changes, in other words, where the points are, is with a reflection. Now, there's no way to reflect that down directly. We also need to slide it. So we're going to need both a reflection and a translation. We need to have both of those, which is what gives us a composition. The third part of this question is, what is the composition? That's got some flexibility to it. So you have the ability to slide it first and then reflect it, or you can reflect it first and then slide it after that. I personally like to get the orientation correct first and then slide it to where I need to. So the easiest thing for me to reflect that over in order to get the orientation in the correct direction is to reflect over the y-axis. So if I do that, if I perform that reflection, point C is 3 units away, so I'm going to put point C 3 units there. Point A is 5 units away, so I'm going to put that point there. So there's A prime, and there's B prime, C prime, and B prime is right up here. So there's my figure, very roughly drawn. Now that I've got that there, I have to figure out how to slide it from its current location down into the correct position. So if I'm looking closely at it, I'm just going to pick one set of points because all 3 sets of points move in the exact same way with a translation. So from B prime down to B prime, I'm going to have to go down 1, 2, 3, 4, 5, and I'm going to have to go left 2 units. So that means it is a translation, -2 units, -5 units. So 1, 2, 3, 4, 5, 1, 2. Perfect. So right there is our composition of transformations. If we then put in parentheses triangle ABC, that means if we start with triangle ABC and we perform a reflection over the y-axis first, then a translation, we have it perfect. If you wanted to do it the other way, it's a little bit tricky. You basically have to slide it so that it lines up where it would be able to be reflected over the line x equals 2. If we slid it there first and then reflected over that line, we could do it. But I recommend doing the reflection first. There's actually a name for this, and we're going to take a look at it on the next page. And that name is called a glide reflection. Okay, and if we look closely, this theorem says that a rigid motion is either a translation or reflection or rotation or a glide reflection. So the third one there fourth one there showcases us a glide reflection. Notice that it is a reflection first, then a translation if we read from right to left. So we just want to be careful as we're doing this. Now, our last example is a quick one. So here it says that the digital artist is reproducing a pattern from a partial tire print from a crime scene. This is a real thing. People who work in forensics do use these transformations to be able to put together pieces like this. So if you have a criminology interest, this is a great example of how we use math in criminology. So here, she said she uses the rule reflection over the y-axis and then a translation up just a little bit, 0.01, is going to recreate the pattern. So what I'm going to do is take just a selection of it. So if I look just at that piece there, and I'm going to really even highlight it just to this little section. If I were to reflect that across the y-axis and then slide it up ever so much, it would fall right into place. I'm going to take away my terrible drawing so you can see it. If it reflects across that y-axis and then slides up just a little bit, it fits perfectly. So this is a rule to perform this transformation. So we've got our 4 different types of transformations. So we've got our reflection, our translation, our rotation, and our glide reflection. A flip first and then a slide. If you guys have any questions, please bring them into class tomorrow, and we're going to dig into this a little bit more heavily when we get there. Have a wonderful night, guys. Bye-bye.